I thought I'd start out. I'm actually going to talk about two types of infinity. The first, given I'm an astronomer and an astronaut, the infinity looking out. I had to start with this. This is, NASA put this picture out from the Webb telescope. They put it out just before Halloween because it's kind of ghostly. It's a picture in the sort of farther out in the infrared where you don't see very many stars, and so it's kind of this gray, ghostly look, which is very different. You can even see, the red eye. It looks a little bit like a monster. So good Halloween picture. Taken, of course, by the Webb telescope, which now is our most powerful telescope, although Hubble continues to work out there. So you have this in the medium infrared, closer to the infrared, then you get a lot of stars. And just to remind you, this is the iconic pillars of creation, which was first made famous in the Hubble picture, which, I still get goosebumps when I look at this. I mean, it's stars being born, let there be light. I mean, it's almost biblical when you think about it. People talk about Webb replacing Hubble. No, that's not the way it works. The two are going to work together because together they span all the way from way out in the infrared to the ultraviolet. And when they work together, looking at this spiral galaxy, and the infrared, you can see the dust, the ultraviolet, you can see the stars being born. I mean, it's just spectacular. But what is really the most spectacular and mind-boggling, these are the so-called deep fields, where you basically take Hubble on the left, Webb on the right, you point them in a direction of the sky, sort of about what you would see if you looked through a soda straw. Other telescopes, they don't see anything. But there's thousands of galaxies out there. It's just extraordinary. And with Webb, you're seeing galaxies far enough away. You see all these funny lines. Those are actually gravitationally imaged galaxies that are much, much farther away. It was Edwin Hubble who first realized that, first of all, that these fuzzy things are galaxies rather than just clouds of dust in our own galaxy, and he called them island universes. And he was able to show that by and large, most galaxies are moving away from us. And the farther away they are, the faster they're moving, which is exactly what you would expect if everything started, in a very dense, condensation, and then a big explosion, everything is moving out. That's what people call the Big Bang, which we've now come to accept. It was controversial for a while. So the universe is expanding away from us, but of course we know all matter in the universe has gravity. So we all knew that the expansion of the universe would gradually be slowing down. One of the prime goals of the Hubble telescope, one of the first big research projects, was to measure the rate at which the expansion of the universe is slowing down. Unbelievably, what they discovered, totally against all of our intuition and everything we understood about gravity, is that the expansion of the universe is not slowing down. It's accelerating. There's something that's pushing things apart despite all the gravity in the universe. And they called it dark energy. And it's nice to give it a name because it makes it sound like you know what you're talking about. But in fact, we don't have a clue about dark energy. What we have found out, though, not through Hubble and Webb, but also through another type of telescope which looks at the background radiation left over from the Big Bang, is extraordinarily, dark energy is almost 3/4 of the content of the universe. And then there's this dark matter, which dark matter has gravity, and there's about 5 times as much dark matter as there is regular matter. And we know where the dark matter is. It surrounds galaxies, and it actually kind of holds galaxies together and may have been responsible for the formation of galaxies originally. But the extraordinary thing to look at here, dark energy and dark matter constitute about 96% of the content of our universe. everything that we're made of. And I, I tell this to my students, I'm sorry, but all the physics and chemistry and biology that you've been working so hard to learn, it only constitutes 4% of the universe. You know, what do we do with that? It's a real mystery. I suspect someday technology will be developed out of all of this 96% of the universe and will probably totally transform life on Earth just the way other sources of energy and, you know, nuclear, electricity, things which once were a mystery, but now we understand and they're part of technology. Right now, we don't know what it is. So we're stuck with a 4%, which isn't too bad. I mean, you know, we got a lot of good stuff here with this 4%, our solar system, and of course, the Earth, which is what we're all here talking about, the stewardship of the Earth. And this is the second infinity that I want to talk about. You know, the universe, yes, it's infinite, looking out. The infinity about the Earth is the concept that most people have about our planet. Now, this probably doesn't apply to people here. We know we live on a finite planet. You know, you can barely see any atmosphere around here. When you see a little bit closer up, you can see this from space, you see this very thin blue line. Yeah, you can see this here. You go out on a nice clear day and the blue sky looks like it goes on forever, right? It really doesn't. And yet, it's this, you know, people treat the atmosphere as though it's infinite. We can put anything we want into it and it's not going to make any difference. It's not true, and that's to somehow share this perspective from space with people on the ground. If we can just get people to appreciate the Earth is not finite, the atmosphere is limited, our oceans are limited. You can't just keep putting anything we want to into these and think that it's not going to make a difference. I wanted to finish up with just a few images of what the Earth looks like to my colleagues and to me, you know, when we're in space looking back. You know, you see cities like you never would have seen them before. Beautiful deserts. I mean, there's a lot of beauty in the Earth. Mountains. I'm a mountain climber. I love pictures of Mount Everest and the Himalayas. Glaciers going into the ocean. I mean, just so much beauty. In the Caribbean, the tongue of the ocean with all of these incredible patterns underneath. Vast storms, hurricanes that you can see, again, with this very thin blue line, which is our atmosphere. There's also some things which cause you to actually, you know, look again. You'll hear many people who say, oh yeah, from space, the Earth is one. You don't see any boundaries. I even hear some of my astronaut colleagues say that from time to time. It's not true. You can see this boundary between Namibia and Botswana. You see boundaries between Paraguay and Brazil, between Mexico and Guatemala, between Israel and Egypt, because of human agricultural practices. And so the thing that you actually become aware of looking at the Earth from space is that the impact of humanity on our planet is now visible from a cosmic perspective. And that really makes you, you know, it can be scary when you think of it about that way. During my almost 20 years as an astronaut, I flew over the Amazon numerous times, and this was back in the 80s and 90s. So, you know, you start by seeing these little roads go through, and then they burn away the grassland, and then they cut sort of almost dendritic, going out in different directions from the primary road. More fires. Sometimes the fires are so dense that you can't even see the ground anymore. And then finally, this is what we end up with. And remember, this is the 80s and 90s. Things have not gotten any better. So what I want you to do is sit back, imagine that you're looking out the window of the space station. This is time-lapse of the Earth going by. And it's what I want to leave you with, because really we do have a beautiful planet, and we've got to take care of it. And that's the stewardship of our Earth is what this whole TEDx is about. So again, you see that thin blue line of the atmosphere, volcanoes from above. And this is the cupola on the space station, which is where these pictures were taken from. A celestial sunset. And the Earth at night is just extraordinary. You really see human civilization spread out in front of you. And this brown line, it's like a halo that surrounds the Earth, the oxygen and nitrogen atoms giving off the energy that they absorb during the daytime. And then of course the aurora, which we actually fly right through. It's just a spectacular sight, the greens and reds of the nitrogen and oxygen atoms. You all recognize this, I'm sure. Yeah, here we are. And now you're starting to see one of the most incredible things from above is thunderstorms, lightning. Here's Denmark, Sweden, Norway, the Baltic, the Nile River, the Nile Delta, Tel Aviv, Jerusalem, Cyprus, Ireland, United Kingdom, Paris. Going down the west coast of South America, again with these incredible lightning storms. And now a celestial sunrise. So in the end, we are so lucky to have a planet like the Earth, and you really appreciate that when you're in space and you're surrounded by a vacuum and you realize how hostile most of the universe is to life. And then you look down and you see our incredible planet. And that's what we are in charge of. I just want to end. I heard this recently, and I liked the idea of passing it on. We have not inherited the Earth from our ancestors. We have the Earth on loan for our descendants. And that's the way we have to think about our responsibilities for the stewardship of our planet. Thank you.